In this video series, I'm going to be focusing on data engineering. I mentioned right at the beginning that data engineering is something we have to pay attention to as we try and train machine learning models, because machine learning models rely on data. Without data, there can be no machine learning model. Well, because a supervised AI system is trained on a corpus of training data, the fundamental question becomes, where is that original data set coming from? Think about it, right? Typically, you almost always start off with an original data set, and you don't even think about where it came from. And then you say, okay, I'm going to split this original data set into a training data set and a test data set. You know that the training data set is what we actually use to iteratively tune the hyperparameters of the network. And the test data set is held out in order to actually give an unbiased perspective on how well the trained model is really doing. Training data is typically further split up into the training data set and a subclass that's held out for validation. The validation data is effectively there in order to assess how well your model is picking up in terms of skills, that you're making the right changes to the hyperparameters while you're training. So the model training process is really the training set plus the validation set. Okay, you know that so far. And then at some point you say, well, I have a very effective model that works well with my validation data set. Now I'm ready to put it out there. And well, when you are ready to assess it, well, that's when you put your test data set to use, and the final accuracy is what you often report. Now, this is a very typical data processing part, and we all tend to focus on the machine learning side. But the key question that I often ask is, where did the original data set come from? It's extremely important that you learn about this process, because without the data, you really don't have anything to train on. And there are lots of nuances about building this original data set. And that's what I want to get through in the next couple of videos and the content that will follow. Good data is absolutely necessary for us. Why? Because if you have good data, it'll give you a good accuracy. But in order to get good accuracy, you have to ask yourself the fundamental question, what problem are we trying to solve? What does that mean? Well, first and foremost, your data has to contain the useful features. If you're obviously dealing with something like images, for instance, well, if the images are blurry, is that any good? What happens if your microphone is not picking up much of the sound and it's supposed to be picking up, but you have poor quality data there, right? So the data in that case is not really useful. The other part is, can a human, for instance, actually distinguish between the examples of each class? Now, the reason this is extremely important is because someone has to label the data. So the human is the actual expert who needs to know whether there's a cat or whether there's a dog in the picture. And if they don't know the difference between a cat and a dog, well, then you've got a problem. Similarly, if you're trying to label cancer data set, then you have to know the structure of a particular cell. Can you do that? Well, I can't do that because I don't have the domain knowledge. So you got to think about what problem you're trying to solve and then find the right people to help with labeling that data. Then you've got to ask your question of, how exactly are you going to assess the performance of that particular model? We talk a lot about accuracy in the context of keyword spotting. And as I told you, yes, you can look at it from the model perspective, but then there are also aspects of the system level efficiency. And there's also this quality of experience that the end user has overall. And so you've got to really articulate all of those requirements when you're capturing the data. And after you figure that out, then there's a notion of how much data do you actually really need, and what quantity, does that data really have to be? At what scale do you want to capture this data? So for example, if you're trying to collect data that's in the context of vision and speech, you need to think about what are the fundamental attributes of those sensors that need to be reflected carefully in terms of the quality of data that's coming out of those sensors, and how much of that do you need. First and foremost, you need to have a wide distribution of training samples. So for example, if it's a keyword, yes, and there's a keyword no, well, you need to make sure you have several thousand of those examples in order to get a wide distribution. So the network is resilient to one particular person's way of speaking that keyword. Then you've got to get accurate labels. If your data is mislabeled, no magical machine learning model is going to be able to compensate for that, right? Because we are training on the labels and because we are using them as the ground truth, then you've got to make sure that you have sufficient number of different items that you want to tag, uniformly balanced throughout the data set. In other words, if you want to classify yes and no, you need to make sure that you have yes and no equally balanced in the data set. So let's think about this more systematically, because in order to go through those questions, there are three stages I want to walk you through. The first one, starting with requirements. What are requirements in terms of building your data set? We talked about this a little bit about the problem definition. And of course, you have to think about what input format, that you want to capture the data, and whether it's a MP3 or a PNG, or it's a simple process, but nonetheless, you need to think about it and actually set it as your requirement. Now, one of the most important things that I want to emphasize here is that you've got to focus on permissions and rights. Often you don't think about that. Today, we take it for granted. For example, I can go on to Google and I can do an image search and I'll get a lot of images and I can put them in the slides here, right? But you got to ask yourself the question, is that data actually accessible? Meaning, is that actually open, that you can directly use it, or do I have to license it for a fee? Now, there's also the subtle issues about, is a person, for instance, in that image, is that person identifiable, and is that okay? Or is it okay to have a person in that picture to begin with? These are subtle nuances, and we typically don't think about these all the time. But if you are a TinyML engineer, then you come to me and you say, hey, I trained this model. One of my first questions is going to be, where did you get the data set from? And if you answer to me, I don't know, most likely I'm not going to be hiring you. That's because the model that you've trained, that IP, that intellectual property that we've created, well, it might be tainted. And if it was tainted on the data for which we did not have explicit permissions, then that's often overlooked, and that becomes an extremely serious problem downstream. Now, let me give you a specific example. Say you're taking a picture. You've got your camera and you took a nice little picture and you're very proud of it. And you're going to put that in your data set. Depending on how you're using your model, which might be trained on the data, you might get into a pickle. Because if that data, for instance, has got critical logos, brand images, or some sort of property in there, and your model is actually providing, some end user value in order to be able to pick these things up, well, you need to be careful, because those models, properties, brands, for instance, they're all copyrighted properties. And so, which means that you don't have the permission for accessing that. And so you have to make sure you actually have the right permissions set up, and only then can you actually use the data, because the image actually has information in there. While the image is yours, the information that's inside it, though, might not belong to you. That might seem crazy to you, but it's totally true. You have to be very careful. Similarly, in speech, for instance, you're collecting the data. You've got to make sure the people who are giving you the data have also agreed in order to use the data. In order to train a model, for instance, if it's not written down in the license file, then you're going to get into a serious problem. And you actually have to, when you actually use that speech to train a model later on to do inferences and deployments, then this might actually come up as an issue. So many different types of licenses exist out there. I'm giving you some examples of Apache, BSD, and Creative Commons licenses. You've got to understand, which of these licenses actually matter for you, and you've got to make sure that the data has the corresponding license. In fact, as homework, I want you to go and look at what's the license for the speech commands data set. Then you've got to think about, how am I actually going to go and collect the data? How do I actually ensure that I'm actually getting the right labeling put in there? What kind of labels do I actually need? And is that just a cat or a dog? Or is that a cat, a dog, and a mouse? And also, you've got to think about the data sources from which you actually want to collect this data. So let me talk a little bit about this, because it's specifically relevant to TinyML. Well, you're using sensors. So now you've got to think about, do you have enough of these sensors that are deployed everywhere that you're actually going to get a rich collection of that data? You've also got to think about where these sensors are going to be. Let's say you want to collect, volcanic activity, because you're training some sort of TinyML application that does some, good around nature. Well, if you're collecting sensor data, you've got to think about, well, how often and how much power and energy does it consume? Because it might have implications in terms of the cost of building the data set. Because if the sensor needs you to constantly go and replace batteries in the computing system because it's using too much power, Well, that's not going to be a very effective way of sourcing your data. Crowdsourcing is a different way of collecting data from different contributors. So contributors, you have like people like you and me, but then we also have enough contributors through volunteers to generate, and can we have a large enough pool of those volunteers to generate the data set? We'll talk about this in the context of speech commands again soon. And let's say for a particular product, do you have the consent? You have the rights, the privacy issues figured out, as well as, we got this issue of maybe like I can pay people in order to actually contribute data. And we'll talk about this in the context of Mechanical Turk later on. Now that's a whole gathering, a stage. There's a whole gathering stage that we come to then, and then we go on to the refinement stage. So you've got to process the data, and you've already seen some of the processing, for instance, that we looked at earlier, of course. And then you also have to do data augmentation, which is another form of processing. For instance, you want to go and do some sort of basic cleanup of the data, like checking things. For instance, is the mic actually working when you're looking at the recordings? Or are these recordings basically empty because the mic was not working? Occasionally, it totally happens that you might get data because you're collecting it at scale, and you might get data that's not of very high quality. So you need to go and validate that data. You cannot just use the raw data. And that's the key message I'm trying to convey out over here. So let's talk a little bit about what data is actually useful. You've collected the data now, and you're trying to validate or verify that data. And then you've got to keep in mind that verifying the data is very tedious because it's manual in some sense, and it'll cost you time and a lot of money as well, because you might have to hire individuals to go and listen to every single one of those keywords, for instance, and make sure that every file actually has the right keyword. Maybe there's a sound in it. Well, that's great. The mic was working, but actually, did they actually say the right keyword? And when they're supposed to say, yes or no? What if someone was being malicious and having a bit of fun and sort of saying yes, and they actually say no, and you're actually polluting your data set. So you've got to be careful in that case. So you can certainly use some level of automation, for example, to detect if the sound or there's no sound in the recording. Well, that's pretty easy. You can automate that. And of course, as I was hinting earlier, you've got to have the right domain expertise. For instance, you might be thinking, look, I've hired person X as a domain expert, and they've labeled data like this. Well, does everyone agree with that particular person's way of labeling, or is there some nuance, to the way of doing labeling that's supposed to be slightly different? So that might lead to disputes or disagreements, and you've got to be careful about that. I know this sounds like a lot, but it's true. And a lot of, it's a lot of work, and that's why most people don't talk about the data set. But actually, data engineering for data sets is extremely important, and very useful to know. The final state is really about sustainability. You've got to store the data someplace. Are you putting it in some sort of cloud service? Because if that's some sort of cloud service, does everyone have fair and equal access to that data? You might not think about this, but certain regions and certain countries in this world have very strong restrictions about what data is actually publicly accessible and what data is not, right? So for example, in the European Union, they have the GDPR restrictions, which take data sharing and privacy very seriously. And there are laws and rules around that. And you have to conform to that if you want to share with that region. Then, of course, is the data secure? Depending on what kind of data you're talking about, sometimes you have to worry about security of that data. For example, if it's my medical records and a machine learning model is being trained on it, well, I hope no one is actually accidentally putting it up on Google and then making it completely accessible by mistake. And of course, there's a chance that there are going to be errors also in your data. And of course, you're going to be then, there's this issue of versioning, right? You collect a bunch of data, but that's not it. Data engineering is a continuous process. You keep updating the data, which means that you've got to remember what data you originally trained your version number 1 model on, what data did you train your version 2 number model on, because you're going to keep improving the model. And if there's something wrong, with that model, that means that you need to be able to go back and check whether the data was tainted in each version. So it's very similar to code versioning, which you're using as you use GitHub or something in order to keep track of the versions And so you've got to do that with the data, with data versioning as well. So the question now is that, as you store the data, we have to also consider how and why data will evolve. Well, that's because the demographics might change, for instance. Let's say that you want to build a speech commands data set today. Soon you realize, well, the volunteers who contributed into the speech commands data set, well, they come from probably a very small subset of the entire planet. That the way that you and I say words might be different, even a little bit. And what this means is that you are learning, your speech commands. Now you have to have your own sounds actually recorded. So because you're getting, informed as you're building the data set, now we need a bigger distribution of that data. And of course, expanding the user base, more number of people, we need to have just more amount of data. And so we have it to become much more resilient when we are training our models. And so I've talked about requirements, gathering, refinement, and sustainment. And so this is, one of the critical workflows you need to keep in mind in terms of building the data set. Often, again, as I've said, people don't talk about it, but it's extremely important that you go through these stages. And the bold ones that I've highlighted earlier are all extremely important ones. So pay extra attention to those. Now, generally, building data sets requires an insane amount of work, as you can see. Typically, you're used to using ImageNet. ImageNet has over 14 million images in there. And it's one of the big reasons why we are all here today, actually. It's because when ImageNet was created, it set off this competition where everybody was competing against being able to classify images correctly from this ImageNet database, which is an awesome thing to do, but you need a lot of images. ImageNet had 14 million. COCO, so another data set for detecting objects, is just as big. It has 2.5 million segmented images. So I'm trying to give you an example of the scale of these data sets. And if you look at the driving data sets like Waymo's open data set or the Kitty 360, well, again, here you can see it's a huge volume data. Waymo, for instance, has nearly 1,000 20-second driving segments of information that comes from cameras and LiDARs. That's every 20 seconds, it's like 200,000 frames of data that's in there. So it's a massive amount of data that we're talking about, right? So this might, so you're actually getting, inputs from 5 LiDARs, 5 cameras, 25 million 3D bounding boxes of labels across 28 object classes, such as, car, bus, bicycle, pedestrian, motorcyclist, bird, pole, and so on. Similarly, Kitty, is another popular data set that's used in autonomous driving, and it's got data that's, about 73 kilometers of driving data that come from many different sensors and laser scans, as well as static images, in the form of cameras. And so that's a huge volume of data. And then you have to process all of this data. And usually, I remember taking this new scenes data set and downloading it, and it took over 140 gigabytes of data. I had to get a separate hard disk just to store the new scenes data set to start training on. And this is an example of the Kitty data set, and people have been using it as, a standard to benchmark their algorithms on, say, monocular depth perception or localization using just monocular cameras. Again, as a summary here, look at the scale of this data, right? Common Voice, for spoken audio has over 5,000 hours of speech data, which is huge. Common Objects, ImageNet, Waymo, all of these data sets are huge. So what is involved in building these data sets? How would you go about building your own data set? How big should the data set be? Is a question, in itself, because the wisdom generally is that more data is always better. So let's start, to understand this a little bit about how you would build your own data sets for TinyML. We'll pick up in the readings and the recordings next and try to figure out, how to understand this process as you go about doing it.